So in this video, I'm going to show us how to enter in data. This will be linear regression data to end up with a line of best fit into Desmos, and to how to scale your X and Y axis using it, and how to come up with a line of best fit on Desmos. And then we'll answer questions that are those sentence frames for the scatter plots. So to add a table in, you come up here to the plus in the top left corner of Desmos, and then you click on table, and then you're going to enter in your X values and your Y values. Okay, you want to make sure that they are matched up because they are points. Usually what I do is I go and I enter in all my X's, and then I go and enter in all my Y's. So let me just enter in those values, and then I'll rejoin us and show us what to do from here. So I've entered in all of my data, have all of my X's and Y's. I would highly recommend just double checking and making sure that you did copy and type them in properly so that it doesn't affect your line of best fit. So now let me just get this to be a little bigger here. And right now I cannot see these. Now if I zoom in, I will be seeing them. Now the problem doing this is when I'm zooming in, the one, I'm trying to get all the way up to the thousands, but here I only need to be in hundreds. So as I zoom in and out, it keeps the scale the same. So you see how this is 500, 500. Well, my X's are going up to the thousands, and the highest is going to be, let's see, 2,450. My highest Y value is 405. So I don't really need to have this side all the way up to 1,000. So what I can do is I can come over here to the wrench, click on it, and I can adjust my X-axis and my Y-axis accordingly. So I'm going to go 0 to, let's see, the highest was 2,450. So let's say I go up to 2,500. Okay. And then my Y values are going from all the way up to the highest was, looks like a 405. So let's say I go up to 410 maybe. Oops, what did I do? I'm sorry, this one I wanted to be 0, and then this one I wanted to be 410. Okay, and then I can click out of it, and now I can see my graph a little better. Okay, it's scale there. So now as it's going in, I can see the scale is slightly different than this, so it allows me to kind of see the shape of the graph a little easier. So now what I want to do is I want to come up with a line of best fit. So to come up with a line of best fit for this data, I'm going to type in Y1, and the reason I'm typing in Y1, and I'm going to type in X1 and Y1. So I'm really going Y equal, let me just type it in, Y equal MX plus B. That's what I'm trying to get, but I want it to use the Y1s for my table and the X1s for my table. So I'm going to go Y1, and I just type in 1 and it'll drop it down, and here X1. And then what I want it to do is I want it to take all the ones that we had here. So I'm going to come here to where the keyboard was, and I'm going to click on ABC. And I'm going to go all the way across here for the symbol. Okay, similar symbol, or like in Spanish, the tilde. And that is what I use anytime I want to come up with any type of line, curve of best fit. So I want to use whatever my table is. In this case, my table values are X1, Y1. So I put Y1 anywhere where I would have a Y, and X1 anywhere I'd have an X. And then again, this symbol here is what I use if I wanted to come up with a regression. And then you can see here is my line. Okay, you can see my data following it. Now it also gives me my correlation coefficient R. R is equal to 0.7621. So your correlation coefficient should be between -1 and 1. If it was negative, it would be a decreasing line. This is positive because it's an increasing line. The closer it is to 1, if it was 1, every single point would be on my line. Every single data point that I plotted would be on my line. If it gets further away from 1, closer to 0, but further from 1, the further it gets from 1, the more spaced out the points are from the line. Okay, again, the closer to 1, the closer those points are getting to your line. You can also see my equation here. My slope is going to be 0.109768 is what they're giving me as an approximation here, and 98.24. So if I was to enter that here, let's say I entered in y equal 0.1x, and then plus, let's say 98. Okay, I'm just kind of approximating it a little. Okay, you see how it's slightly off from this, but that's about what it would be. Okay, let's say I do 1, 1. Okay, 1, 1 would make it fit better there. So that would be my line of best fit. Okay, so what I'm going to do now is I am going to put this onto my cami paper, and then I'm going to answer some questions. Okay, so let me pause for a second and do that. So I put these, the graph, okay, from Desmos here. I also put how I typed it into Desmos, y1, okay, that symbol, kind of like the similar symbol, mx1 plus b. And here it gave me this. And let me just kind of highlight here that this right here, this is your correlation coefficient, okay? Okay, that's going to be called our correlation coefficient. Color. Correlation coefficient. And that correlation coefficient is always in between or equal to -1 to 1. And so this one is positive because it's an increasing line. I would say it's closer to 1 than to 0. So this would be somewhat strong correlation. And again, it's a positive correlation. These down here, this is my slope. And this is my y-intercept. And then here below, I wrote the line of best fit. So this is my LSRL, or my line of best fit. Okay, I approximate it as a 0.11x plus a 0.98. So now we're going to answer some of the questions. We're going to describe the scatter plot. We're going to interpret the slope, interpret the y-intercept. We're going to interpret the correlation coefficient. And I'm going to also have us predict a point and then talk about the residual for that. So when I describe the scatter plot, what we're going to be doing is we're going to be basically saying there is a strong or weak, positive or negative, linear or nonlinear relationship between whatever our x is representing and whatever our y is representing. And I should actually label what my x and y are. So let me get a text box here. My x was the house in square feet. Okay, so this is house in square feet. And my y value is going to be house price in thousands. Okay, house price in thousands. So let me just adjust this, and let me get my text box. And I'm just going to type here house price in $1,000. Okay, and then let me flip it back. Oops, sorry, I need to flip it this way. Okay, so here is my house price in thousands, and over here is my house in square feet, okay, or size of house in square feet. So when we're describing a scatter plot, looking at it, this is positive, it's increasing, okay. This is pretty linear, and again, it was relatively strong because of this R here. So I'm going to describe the scatter plot. Let me just get my text again. And I'm going to describe it by saying the following. And let me kind of get this up a little bit. So I'm going to say there is a strong positive linear relationship between, and I'm going to talk about between what two things? Between the square footage of a house and the price and the price in thousands of dollars. Now, the next thing we're going to talk about is the slope. Okay, so we're going to interpret the slope. So I'm just going to grab a new text box. And for this, again, we're going to interpret the slope. So interpret slope. And so for this, I'm going to say what the slope was. So remember, the slope in this problem, we said was about a 0.11. Okay, so 0.11 was our slope. And so what we're going to say is how that relates for this to this particular problem. So we're going to say as the square footage, because this is your x, of a house increases by always 1 unit, because we want to know how much it is as a unit rate for the slope. So as the square footage of a house increases by 1 square foot, the price of a house. Now this is where we look at the line to see if it's increasing or decreasing. This is increasing, okay? So as the house size gets bigger, the price gets more. So the price of a house increases by, and this is in thousands of dollars. Now, for this, just a little reminder, since this was in thousands of dollars, if I have 0.11, let me do it in parentheses. So if I have 0.11, and I am going to times it by 1,000, because really this is thousands of dollars. So it's not 0.1, it's not 11 cents. This is in thousands of dollars, okay? And when I do that math, it's really 110. So that 0.11, which it is 0.11, but again, that's in thousands, okay? So that's really going to be $110. We generally aren't going to have ones where we're going to have to convert it like this, but I just want to be accurate for this problem. So as the square footage of a house increases by 1 square foot, the price of the house increases by, and I will write it this way, 0.11 thousands of dollars. Okay, I'll write it like this. But really, what does that mean? Okay, so I'm going to write what it really would mean in terms of actual dollars. And I'm going to, here, I'll change the color. I'll put it in red. Oh, I want to put the text in red. Okay, so I'm going to rewrite that, but with oops, not red. Change it up here. Okay, so as the square footage of a house increases by 1 square foot, the price of a house increases by, and remember that it was, the slope was 0.11, but that was thousands. And so that is really by $110. Okay. Now, the next thing I'm going to talk about is the, let me change the color back to black, is the slope. I mean the y-intercept. So now we're going to interpret, let me get this to be bold. Okay, we're going to interpret the y-intercept. And the y-intercept in this case is, I'm going to write it as a point 0, comma, it was 98. Okay, so 0, comma, 98. Okay, now again, we're going to remember that that 98 in this problem is really 98 in terms of thousands. So that's really going to be 98,000. Okay, so that is the point, but again, remember what it's in. So the 98 is in thousands, so it is $98,000. Okay, let me put my dollar sign in here. It is $98,000. So now we're going to use this to write our sentence frame. And our sentence frame is going to start when and this is when you want to talk about the 0 and you want to talk about the 98. In this case, again, it's really 98,000. So when the square footage of a house is 0 feet, and sometimes the y-intercept does not make sense in the problem, but the equation as your x's get bigger will make sense. So sometimes when it's close to the y-intercept, it doesn't really make sense that if your house is 0 feet, that it's going to cost $98,000. But that's what this y-intercept is, and we write it as is. Okay, so when the square footage of a house is 0 feet, the price of the house is 98, but again, remember, this is in thousands, so it's really $98,000. Okay, so you want to be very specific with that. Now, the next thing we're going to talk about is this correlation coefficient. So before I talk about the correlation coefficient, I have here some examples. Over here you see a positive correlation, okay, where the scatter plot is increasing, it's going upward. A negative correlation where it's going downwards. Here, no correlation, it's kind of scattered. You don't see it kind of going up or down. You can't really tell. Over here, this would be a moderate correlation. This would be a strong correlation. Down here, I show you 1 to -1. Again, that's what your R goes from 1 to -1. And all of these ones here that are positive, they're increasing lines. All these ones over here that are negative, these are decreasing lines. That's what the negative means. Now 1, you'll see all of the dots, the data points are on the line. You see here that they're close to the line, but not exactly on the line. They're closer than these ones are. So this is a 0.8, where this one is maybe a 0.3. Here you see what it would be for 0, where there's no correlation. And again, we have the same -0.3, where it's going down, negative 0.8 where it's getting closer, so the correlation is stronger, and then here, -1. So that's what that R represented. And again, the R I'm talking about is this 0.7621. So it's not the strongest in the world, but it's definitely stronger than weaker. Okay, it's closer to 1 than it is to 0, for example. Okay, so I am going to now talk about the correlation coefficient and write a sentence frame for that. And just kind of in general, in terms of what's strong and weak, just kind of an example here. 0.3 weak, but still positive. 0.5 about a moderate. 0.7 strong, and obviously 1's perfect. And similar with the negatives. Okay. So now I'm going to add a page. And I'm going to talk about the correlation coefficient. And the one we're going to be describing is, again, this correlation coefficient of R equal 0.6121, okay? 0.7621. So I'm going to get my text box. And I'm going to start with, so this is going to be interpret correlation. They might say association. And so we're talking about R, which equals the correlation coefficient. And in this case, RR is equal to 0. And let me just double check, 7621. Okay, 7621. 7621. Okay, so now our sentence frame is going to be since R equal, let me just change the font to match, sorry. Okay, since R equal 0.7621 is, and then we're going to say close to or far from, is close to 1. Okay, so it's either going to be close to or far from 1 or -1. If it's positive, it's always going to be compared to 1. If it's negative, it's going to be compared to -1. So since R equals 0.7621 is close to 1, there is a, and then you're going to say strong or weak. We're going to call this one strong because it's above a 0.7. Positive, linear relationship between, and again, at this point, this sentence is pretty much like our describe the scatter plot, right? So there is a strong positive linear relationship between the square footage of a house and the price in thousands of dollars. Okay. Now, the next thing I'm going to do is I'm going to have us use our line of best fit, okay, this one right here, to make a prediction, okay? So let's say I predict what should a house that is 2,450 square feet be? Well, we say the price of that should be 324,000 in terms of the table, actual data. We want to know, well, what is it in our predicted model? Okay, so I'm going to use the 2450 in this 0.11x plus 98. So let me just get here, get a new text box. So what we're going to do is we're going to predict the cost of a house that is 2,450 square feet. And so what we're going to do is we're going to use our LSRL. And our LSRL was y equal 0.11x plus, and I want to say it was 98. Okay, so 98. Now I got to remember that when I get my answer, this is really going to be in thousands. Okay, so what we're going to do is we're going to substitute 2,450 in for x and find the y. Okay, so we know it's going to be y equal 0.11 times 2,450 plus 98. And when I put that in my calculator, let's see what we get. So when I put that in my calculator, back to the same font. I don't know why it keeps wanting to change. Okay. We end up getting, so 0.11 times 2,450 plus 98 gives us 367.5. So we ended up with 367.5. Now remember, this is in thousands, right? So this is in thousands. So really, if I was to times that by 1,000, it is 367,500. So it's going to be really $367,000 $367,500,000. That would be our prediction. Okay. So now what they like to ask us is, okay, that's our prediction. How far off were we from the actual? So now I'm going to open up another text box here, and I am going to figure out a residual. And so what a residual is, it is how far off we are. So this is how far off was our prediction from the actual data, okay, from our table. That's what residual is. And the equation for residual is actual, and again, this is from table, okay, or from your data, minus predicted, and the predicted is from equation. So if I want to find the residual, so find residual for a house that is 2,450 square feet. Okay, we've already found our predicted using our equation. And now we need to figure out what our actual is. Okay, so if I look up at our table, I see that our actual is going to be right here. This is our actual. So it was 324,000 was the actual. So if I come here I am going to take that 324,000. Okay, that is my actual. So 324,000 is what it was. Okay. Minus my predicted, which was 367,500. And that's going to tell us how far off we were. So when I do that math, 324,000 minus 367,500, I end up with a negative 43,500. So a negative 43,500. So what does that mean? Since it's negative, and we're taking the actual minus what we predicted, we over-predicted. We over-predicted the price by $43,500. That's how much we over-predicted. So where would that be up here? So if I'm looking up here, okay, this was 2,450, 2,450. So, and it's 324. So that's going to be this one right here. So let me just circle that one in red again. So this one right here is the one that we found the actual and then with the predicted. And so what we see is we are off by this much. Okay, so this is what we predicted up here. This is what we predicted up here on this line. Okay, and this is what the actual was. So the difference between this is what a residual is. Now, if we're looking at the Desmos, what you're going to find is we will see this residual. It actually will plot it for us. So let me get that back up and show you how we do that. So here, again, the distance from these actual points to the line is what a residual is. If the point is above the line that we have, it's going to be a positive residual because it's actually higher than what we predicted. If it is under the line, then we're going to get a negative residual because it was less than what we predicted. Okay. Now, if I come over here where you see residuals, it will plot the residuals, and what it's plotting is the value of how off we were. Okay. Now, when I click this, it's actually going to give me those residuals right here. We can see those residuals. Okay. So here you can see that negative 43. Okay. Now, ours was a negative 43.5 because we rounded this 0.11. Okay. We didn't keep it where it was. But you can see we're basically $43,000. It was $43,000 less than what I predicted from my line. Okay, now those residuals are plotted around the x-axis. So it's just plotting above or below the x-axis. You can see that right here. Okay, so again, for a square footage of 1,100, we were off by 19,000. It was 19,000 less than we thought. This one here was 64,000 more than what we thought. And that's what a residual is. So I hope this is kind of helpful guide to us as we go through this chapter.